So a few days ago, the Nvidia CEO Jensen Huang had a special event, a special summit in India where he talked about agents, he talked about the future of AI. Now, it caught my attention because there's a lot of gems, a lot of amazing nuggets that I think us as AI developers, AI enthusiasts, people who want to build real-world applications that leverage AI to solve real-world problems. It's a good reminder of what's happening and what's coming. Play a few clips so you can hear a little bit what he's talking, and I'm going to then add my comments.
And if we were to find ways to apply deep learning to other problems, how does it affect the computer industry? My industry, your industry, that we've built over the last several decades is going through fundamental change.
So, of course, in the beginning here is talking about, of course, what we know, which is the fundamental changes that have been happening all across the industry, booming with AI taking over pretty much everything as we know it. So that's kind of the introduction first.
Seismic change, tectonic shifts. Let's talk about that today. Our incredible partners that we're working with here in India to transform the IT industry together. And so I'm delighted that all of you have joined us today. There are two fundamental shifts that are happening at the same time. This hasn't happened since 1964, the year after my birth, by the install base of your hardware to run your software over a long period of time.
So now he's just talking about the history of software and how it progressed into what we have now, cloud computing and many other things. But most importantly, so essentially he's sort of prepping people to what's to come, which is the revolution of AI and Nvidia being the creator and the maker of GPUs and chips and all that stuff.
Without changing the software, the hardware can continue to improve in an architecturally compatible way, and the benefits of that software doubles every year.
So he's talking about the computer science, the Moore's law. So the capacity that is attached to chips, it was doubling, going at a faster rate. I think it was doubling, but he's talking about that how things are now, instead of doubling or quadrupling, and going exponentially higher.
As a result of doubling in performance every year, Moore's law made it possible for us to continue to drive down cost, democratizing need to use more and more of IT. That the scaling of CPUs has reached its limit. We can't continue to ride that curve, that free ride. The free ride of Moore's law has ended. We have to...
Wow, that's pretty amazing. He says the free ride of Moore's law, the one that things are exponentially growing, the capacity of processor, of computing processing, CPUs and so forth is exponentially growing, that we kind of plateaued, which is very interesting.
Now do something different. Or depreciation will end. And we now will not enjoy depreciation, but experience inflation, computing inflation. And that's exactly what's happening around the world. We no longer can afford to do nothing in software and expect that our computing experience will continue to improve, that costs will decrease, and continue to spread the benefits of IT and to benefit from solving greater and greater challenges. There is no such magical processor that can accelerate everything in the world. Because
now he's talking about processor because that's what his company does, Nvidia. So essentially saying that it's very difficult to have just one tool that will solve all the problems. When it comes to creating powerful GPUs, CPUs, there's just not one thing that will make everything better or everything faster. So there's always this incremental processing that has to happen to get to a higher level of very extremely powerful CPUs, GPUs, and computational power, essentially. This is the part that's very exciting because now he's talking about here about the way software was created, or the way, as we know it, software was created or is created.
The way that software was done, call it software 1.0, programmers would code algorithms, we call functions, to run on a computer. And we would apply.
So this is very exciting because it's talking about, of course, as humans, programming this industry that revolutionized everything as we know it. Everything is software based. But the idea was that human coding, me, you, we would actually write a code or program that would run on computers. So essentially then that would be passing through as a function, and then the function will pass through an input, which then that information will be processed in a computer, and then we get a result. So that's what he calls the software 101.
Apply it to input information to predict an output. Somebody would write Python or C or Fortran or Pascal or C++, code algorithms. That approach of developing software has been disrupted.
Now, this is the part he's saying, this process of writing software as we know it, which human coding and create functions and then pass that into a computer where it runs, it knows how to take that information, the inputs and everything, and get an output. He's saying that is pretty much eradicated or it's obsolete in a way.
It is now not coding, but machine learning.
Aha, so we go now to the AI power, saying it's not coding anymore, it's what we call machine learning. And at the center of everything, he calls this the software 2.0, which means is an increment in terms of how software is created. And it's a very interesting concept because now we have this sense of machine learning creating the software essentially. So it knows, as after being trained so many times with so many kinds of software or code bases and so forth, it knows how to create the actual code that would be running inside of GPUs to create the actual functions in this case. That's what's happening here. Instead of us humans coding the functions themselves, we're just saying that machine learning allowed for all these code bases to be ingested through AI and then being able to actually predict or write code, software in this case, which indeed has to pass through or has to be run through a GPU for this whole creation of software to actually happen.
Using a computer to study the patterns and relationships of massive amounts of observed data to essentially learn from it the function that predicts it. And so we are essentially designing a universal function approximator using machines to learn the expected output that would produce such a function. And so going back and forth, looking, this is software 1.0 with human coding to now software 2.0 using machine learning. Notice who is writing the software. The software is now written by the computer. And after you're done training,
so the software is now written by the computer. Now I understand as a computer person, a developer, a coder, a programmer, this can be scary. But there's something I have to say here. Yes, computers are able to write code, but at the same time, we are not at a point where computers can do everything, meaning machine learning or AI can actually write very complex software. It's getting there, but it's not that we don't need programmers anymore. I don't think we're there yet.
Training the model, you inference the model. You then apply that function now as the input. That function, that large language model, that deep learning model, that computer vision model, speech understanding model, is now an input neural network that goes into the GPU that can now make a prediction given new input, unobserved input. This way of doing software.
So this is the final diagram. So the machine learning, essentially the AI is trained on large code bases. So we can input something, say, write me a Python function or a Python code or Python project that does X, Y, and Z. So the machine, AI in this case, will know how to, of course, use GPU and use that information as input to then generate the actual function, which is going to be the result from the AI that's going to be put through, again, the function into another GPU, so to create the results. So that approximator, as he was talking about, is the AI is going to be able to iterate through or find those patterns because it was trained on a lot of code bases, so it knows how to code. It will know how to generate the appropriate function, the appropriate information that's going to be passed through to generate the actual software. That's essentially what he's talking about.
Notice, it's based on fundamentally machine learning. And we have gone from coding to machine learning, from developing software to creating artificial intelligence, and from software that prefers to run on CPUs to now neural networks that runs best on GPUs. This, at its core, is what happened to our industry in the last 10 years. We have now seen the complete reinvention of the computing stack.
So this is an important concept because AI is here. So he's saying that there's this new reinvention of the computing stack, which means the way things used to be done, it has changed essentially, meaning that instead of having computer programs, we have machine learning AI that is designed to create software, to create code that then can be run as software to build things. So it's a very interesting concept. So we are moving forward into the next phase when it comes to generating code or when it comes to building software.
The whole technology stack has been reinvented. We have now learned the meaning of so many different types of data. We have learned how to represent information in so many different modalities.
Now he talks, I went through a little bit here. He's talking about
images
different
and
modalities. So usually AIs, when it all started, few years ago, what would happen is most of these ChatGPT, most of these large language models were focused more on textual data inputs and output. So multimodal, what he's saying is that now instead of just textual data that we can input, we also have multimodal, different modes. We could have images, text, of course, videos and sounds or MP3 files. So having this multimodal kind of ecosystem for our large language models, it's amazing because now we have a full representation of different kinds of inputs, different kinds of data, what we call unstructured data out there. So it's not just textual, but now we have this multimodal system that large language models are supposed or can ingest and understand and find meaning. Because at the bottom of everything, it's all about the AI revolution comes from understanding that machines are able to find meaning in data. Because when you have data is all about meaning. If you can't figure out the meaning, the patterns of that data, then it's going to be very difficult for you to have AI essentially.
And videos, chemicals, proteins, amino acids, fluid patterns, particle physics. We have now learned the meaning of so many different types of data.
By understanding the meaning of different types of data, we can innovate more, right?
We have learned to represent, how to represent information in so many different modalities. Not only have we learned the meaning of it, we can translate it to another modality. So one great example, of course, is translating English to Hindi.
So we've seen this being able to, large language models are able to finding meaning. They're able to find ways or to translate different languages and back and forth.
Large language models that understand.
Now he goes to the meat of everything, which is agents. So agents in this case are able to do things, to do tasks autonomously, but along with a large language models. Agents work with large language models because then agents are able to go and do certain tasks by themselves or delegate those tasks to somebody else who is also an agent to do X, Y, and Z. And so now you have this swarm of agents that can do things. So that's where he's getting into.
Understand the data that, of course, is being presented. It could be streaming data, it could be video data, language model data, it could be data of all kinds. The first stage is perception.
So he's talking about the stages of what constitutes an agent. So essentially saying the agent is going to be, it is pretty much everything that we need to focus on from here on. And it's been the thing for a few years now. Agents do understand the data that is being presented. That's what he's trying to say here. And it goes through a few stages. The first stage is perception. Again, part of understanding, okay, the things that I'm receiving, the input I'm receiving, what is it? What are the tasks that I'm supposed to do? What I need to know in order for me to be able to do those tasks. Not only that, if I can't do those tasks, or if I need to transfer power to another agent, I need to also be able to do that as well.
The second is reasoning about, given its observations, what is the mission?
Now, reasoning, this is a key point because an agent has to be able to reason through this whole process. So if you give it a lot of tasks, things that need to be done, it needs to understand this perception stage and then reasoning to understand, okay, what needs to be done once it's giving all these tasks, all of these inputs. Right? It has to reason around, just like you and I would do, to reason through a certain problem until we get the solution. So this is the crucial part about AI, about why agents are so important, and they're really going to take over. They already are taking over in the AI industry.
And what is the task it has to perform? In order to perform that task, the agent would break down that task into steps of other tasks. And it would reason about what it would take, and it would connect with other AI models.
There we go. We talk about the swarm of agents, right? The first agent will know, okay, this is what's supposed to be done, and reasoning and perception and everything, and needs to break it down. Okay, what are these pieces that need to be done, right? And then it can delegate, because one agent could be good at marketing, the other one could be good at reading a PDF file, and the next one could be really good at crunching numbers. And so this capability of reasoning, perceiving everything that comes in, and then be able to create those tasks, and be able to pass those tasks to different agents that need to do X, Y, and Z. That is the power of this agentic system that we can create, that can create different things, that is able to delegate and build things and solve a lot of problems.
Some of them are good at, for example, understanding PDF. Maybe it's a model that understands how to generate images. Maybe it's a model that is able to retrieve, supercharge them, make them more productive. Now, when you think about these agents, it's really the way you would bring these agents into your company is not unlike the way you would onboard someone who's a new employee. You have to give them training curriculum. You have to.
Okay, so he goes to understanding that agents, just like people who work in a company, when they are first hired, they need to be trained. So we need to train our agent. Agents need to understand what is that they're supposed to do, how they do it, and have some sort of guardrails around them as well. So essentially, agents are just like people. Well, they're not people, but they're just like an employee that comes into a company, and they have to be trained essentially to know what they are supposed to do and what they're not supposed to do, and evaluation and all these things. So that is the idea. So you can see that where he's pretty much going with this. I bet that he's going to talk about how in the future, literally agents are going to be at the center of organizations, not to eradicate humans, but to aid the actual humans who work at a company, having agents that help humans that work at a company to do tasks or to build things or to work faster and better.
Fine-tune them, teach them how to use, how to perform the skills, and understand the vocabulary of your company. You evaluate them, and so they're evaluation systems, and you might guardrail them.
Okay, let's keep
going. And Nemo is a suite of libraries that onboard API inference microservice.
So now he's talking about here, it's kind of hard to see, but he's looking at this enterprise AI and the APIs that have created that allow enterprise businesses to create these agents and train them. So he calls this the Nvidia Nemo, this AI agent lifecycle library. So essentially mimics the whole process of onboarding people in a company. So it's very exciting because at the top here you can see all of these are agents. We have this healthcare agent, service agent, research scientist agent. All these agents are guided by this Nvidia Nemo, which is the hub, essentially, orchestrator that will onboard them, customize them, evaluate, and also put guardrails around these agents. So essentially, really, you can think about it as having employees, new employees, that they come in and then you pass them through this Nvidia Nemo. These are agents, so they understand exactly what are the things that you're supposed to know and do as part of this organization. It's pretty amazing.
Called NIMS. Essentially, this is a factory that builds AIs.
There we go.
And Nemo is a suite of libraries that onboard and help you operate the AIs. And ultimately, your goal is to create a whole bunch of agents. We have partners here that we're working with in India, and Vishal, give you.
All this computing helped us to leapfrog to the work that we are doing.
Dramatically more impactful. Cars and planes and trains, and created, onboarded, deployed, improved into a life cycle of agents. And so this is what we call Nvidia Nemo. We have, on the one hand, the libraries. On the other hand, what comes out at the output of it is an API inference microservice we call NIMS. Essentially, this is a factory that builds AIs. And Nemo is a suite of libraries that onboard and help you operate the AIs. And ultimately, your goal is to create a whole bunch of agents. We have partners.
So he's talking about ultimately the goal is to create a whole bunch of agents. That's exactly what I was saying. The goal is to have a company that creates a whole bunch of agents that do X, Y, and Z to aid its employees.
Here that we're working with in India. And
asked me a pretty profound question, long period of time. A well-spoken Indian.
We have combine it with your incredible IT capabilities, software capabilities, so that we can create agents and help every single company benefit from it. And so this is the first part. The second part is this. What happens after agents?
So this is the future side of things. He says, now what happens after agents? There's got to be something else. Let's see.
Remember, every single company has employees, but most companies, the goal is to build something, to produce something, to make something. And those things that people make could be factories, it could be warehouses, it could be cars and planes and trains and ships and so on and so forth. All kinds of things. Computers and servers, the servers that Nvidia builds, it could be phones. Most companies in the largest of industries ultimately produces something. Sometimes production of service, which is the IT industry, but many of your customers are about producing something. That next generation of AI needs to understand the physical world.
There we go. So he's talking about that next generation of AI needs to understand the physical world. Now, you can imagine what he means by that. So he's talking about, as he will show here, he's talking about having agents that are actually running in the physical world, which means could be in a way of robots, in a way of something that is physical.
We call it physical AI.
They call it physical AI.
In order to create physical AI, we need 3 computers. And we created 3 computers to do so. The DGX computer, which Blackwell, for example, is a reference design, an architecture to create things like DGX computers for training the model. That model needs a place to be refined It needs a place to learn. It needs a place.
So now it goes back to from having AI agents, which sort of is this abstract world, to transfer that into a physical world where you actually have agents running the show essentially through physical, actual palpable robots, as an example. And for that to happen, he's saying just like an agent had to be trained in some ways, we also need to train these agents that are connected to the real world through robots and so forth, have to train them physically so they understand how to move physically around like a warehouse, around an office, or whatever else in the physical world. So that is the next step after AI, according to him.
To apply its physical capability, its robotics capability. We call that Omniverse, a virtual world that obeys the laws of physics, where robots can learn to be robots. And then when you're done with the training of it, that AI model could then run in the actual robotic system. That robotic system could be a car, it could be a robot, it could be it could be a autonomous moving.
So most of it actually we kind of see happening already, but it's in a different environment in Nvidia kind of world, Omniverse as he call it. Very exciting, very exciting.
Robotic could be a picking arm. It could be an entire factory or an entire warehouse that's robotic. And that computer we call AGX, Jetson AGX, DGX for
Our system integrators.
short video to help you put everything together that I just said. Run it, please.
Okay, so there's a video that essentially goes through everything that he said. All right, I will stop here, and you should have access to this video, the full video. It's about 44 minutes and so forth. Didn't want to make this too long, but I just want to say it's very exciting, and for some it may be scary. I don't see it as a scary thing. The thing to keep in mind here as developers, as people who are building tools in AI, there's just so much out there. This is not going anywhere. It's not going to slow down. And so my advice to you, instead of being scared of, okay, this is happening, maybe I'm going to lose my job. Yes, there may be some things that people are going to lose. That's just part of revolution, part of the moving forward in the world. This happened many, many times from the Industrial Revolution to right now. But as developers, I think we need to start thinking about how to use these tools so that we can actually solve real world problems. In fact, this is the reason why I have a community that I opened that you can join, where I literally envision and talk about how to leverage what you see AI in general, AI agents and so forth, how to use AI and coding skills to actually build real world solutions. Go ahead and check it out in the link in the description. As developers, how do we need to think about this? As I said, think of it as an opportunity to start seeing the patterns. So patterns are very important. If you don't believe that, imagine that all along when we talk about large language models, training and everything, it's all about patterns. And so if you understand that, that means if machines, what we'll know of this whole thing that we know of AI revolution, it's all about patterns. That means that we need to focus on the patterns of the industry. Where is this going? Well, AI is going to be the fundamental building block of the AI revolution, essentially. So understanding how to build agents, understanding how to customize agents, understanding the value of agents, that's where we need to start focusing more at this point. Of course, things change, but put our focus there because that is where exactly where the industry is going. That's what we are seeing in the industry. Besides just him talking about agents, all over the industry, you can see there's all these frameworks that are and platforms that focus on agents, AI agents. And so that is what I need you to take away here, is that as developers, this is good news, right? This means that we have something to hold on to and really hone in our efforts so that we can actually ride along on this amazing, exciting wave of AI, specifically when it comes to agents, to build things that actually make sense, that actually move the humanity forward. And I mean that, right? So thank you so much for your time, and I hope this was helpful. If you're new here, make sure to go ahead and subscribe and like this video, share, and leave in the comments below what you think of this whole thing. If you believe in it, if you think it's a good idea, if you think it's a bad idea, what are your thoughts? I want to hear your thoughts. Let's continue the discussion and go from there. Thank you, and until next time, be well.